Find yourself having lots of data in Elasticsearch, yet it can't do this one thing. This talk's for you. Okay, so for this video, what I'm going to do is I'm going to go ahead and go to this GitHub page for H&A Security Solutions Elastic-ILM. It's where we're working on our own customized index lifecycle management that'll work for the open source edition through any version of Elastic. And in here, at the very bottom of this, I kind of walk through a demo workshop, which is what I'm going to cover here because it really shows a lot of the fundamental Elasticsearch to Python connections. And when I do this, I obviously have documentation here, so if you want to follow along, maybe follow along. So in here, what I'm going to do, I've already got this downloaded. I've got on my box, I'm going to switch here to an Ubuntu shell. I've got the opt Elastic ILM GitHub project downloaded. And in here, I have a demo folder where you can do docker compose up, and it will launch an Elasticsearch instance in the background, because it's kind of safe to have your own Elasticsearch cluster single node that you could blow up without getting fired. So we're going to play with that demo instance. And then from there, in this project, I also have where we can launch Jupyter Notebook and start playing with Python manually. So I've tried to document this. So there we go. By the way, up in the top of this documentation, in this folder, you would have to run pip environment install first, so it downloads all the requirements. After that, you could run this command. So from here, we'll go ahead and connect to this string. Bring that up. That authenticated with a token. And I've created this demo Jupyter Notebook to just kind of follow along. So here we go. And this is designed with documentation from a top-down perspective because it's piecemeal. It's kind of walking you through this. I'm going to go ahead and hit kernel real quick, restart and clear output because I can tell it's got some saved output in it. It's not a big deal. So we're going to start over from scratch. These are just libraries that we'll often use. The most important one is probably these Elasticsearch ones. That gives you a lot of the ability to connect to Elasticsearch, insert data, check on indices. Helpers lets you do bulk commands. And there's also this DSL, which just makes an easier query style search syntax. You'll see that in a second. You don't have to memorize all this. A lot of this project and this walkthrough is trying to get you comfortable. There is also a lot of documentation. If you do Python Elasticsearch right here, this guide is fairly, it's okay. The reason I'm making this video is because I had to learn and fight through some of this. The documentation is actually really good. There's just not a lot of examples. Another project I just want to call out because Roberto Rodriguez is awesome. Python Elasticsearch Roberto, and you'll find this Jupyter Notebooks with Sigma rules. It's probably not as comprehensive as I hope this video is as far as depth and range, but he does some really cool stuff that I'm not going to cover in this video, and he's just a really cool guy. So shout out to Roberto there, by the way. So let's go through this. In Jupyter Notebooks, you can hit Shift Enter, and it will run whatever box you're in. So I'm going to hit Shift Enter, and you'll notice there was that little asterisk there, and it went away. That lets it know it's processing, and when it's done, it's done. This section here is where we'll start. To make a connection to Elasticsearch, the default, if there's no authentication, is you just literally point over to the box. This could even be an array containing multiple boxes, and that would be acceptable too. Now, I've also got pulled up here, in this GitHub repository, there's this es.py file. This is where I have the core of most of my functions. I'm not trying to use those for the demo so much just because I want you to see the actual calls, but you can reverse engineer this really well because I tend to put documentation in my code. So for example, I have in here the build ES connection, and instead of doing this simple string in production, I call this function because, well, what happens if you're doing authentication? What happens if you have SSL enabled? Does it require a certificate authority verification? Do you check the host name? All of that's in this code, so if you need to go deeper, it's all in this project. So you can see SSL required, so on and so forth. For our demo, it's just a basic auth Elasticsearch. I'm sorry, it's no auth. It's anonymous. So if I hit Shift Enter, there we go, it's connected. And what I'm going to do is this very first thing, notice our connection is saved to the variable ES connection. Everything we do moving forward is basically off that object. So I'm going to say ES connection, hey, indices delete if the demo nessus or suricata data is there, which it shouldn't be, delete it. Oh, but see, I must have left over data on my machine because it said acknowledge true, so it deleted them. If I run it again, Shift Enter, well, oh, it's because I have a wildcard. Here, watch this. Boom, threw an error. If you scroll to the bottom, index not found. The only reason it's not throwing an error is because when you do a wildcard, it won't have an error. So see, something you learned, then I just, oh, okay, all right. Next, what we're going to do is it helps to actually have data. So I've got some sample suricata logs and Nessus vulnerability scan data that we're going to ingest. Now, the demo data itself doesn't matter. It just gives us something to query and interact with. And I'm going to do it as a rollover. If you're not familiar with rollovers, highly recommend you look into them. But this is because part of this project is to handle pushing rollovers to the next index. So it's going to create an index called demo nessus 1 with an alias to demo nessus. Basically means if you search demo-nessus, it'll link off to the actual index name. And rollovers will keep rotating that index. So we'll run that, Shift Enter. Notice it took just a second. And we're also going to import some suricata data also as a rollover. This one takes a little bit longer. Notice it's sitting with the wildcard here. In a second it'll be done. There it is, true. And so now we're just going to do a simple search. Now this is one of the most important concepts of Python to Elasticsearch because ultimately you want to grab data. So here we're saying, using the connection we've already made, I want to search demo-asterisk. That technically can hit something in suricata or nessus because of that wildcard. Shift Enter. Now nothing's happening yet, it's just getting it ready. Here's where I'm actually doing a search. This line right here is basically doing a DSL search. Basically, it means a more simplified search, such as I could have copied and pasted this right out of Kibana Lucene search, because I am doing a Lucene search with Python. So here I'm saying, hey, I want to find logs that have a source IP of 172.16.0.2 and a destination port of 80, bring it back to Python, and then I can manipulate or do whatever I want with the data. So I search it, we execute the search, and to make it pretty print to the screen, we're actually using Panda data frames. Now, you don't have to do this. I'm going to show a different way of doing this later, but when we run this, the Panda data frame gives you this nice table view. So notice I can see packets to server, destination IP, ports. It's this nice layout. Still not something I would want to replace Kibana with, but I can see what I'm doing with my data. Now, I don't want to necessarily have to keep doing that code over and over again. So just like with any programming language, what you might want to do is turn this into a function that is easier to read and call. So the next thing I'm going to show you is that. I'm going to create a function that's called query Elasticsearch, query ES. That's just short and sweet. Hey, give it an index name that you want to query, and, well, your query. Okay. And you can see a lot of this is really what we just did, but it's hidden behind a function. So we'll run that. And now I'm going to do query the demo nessus index specifically, and different query. I want to look for anything that's a service category. Run it, and hey, it works. Except for in my code, this might be a little bit cleaner and a little bit more logical for me to keep referencing. Now, data frames are cool, and if you're doing data science calls or different ways of analyzing data, pandas, NumPy, things like that are awesome. If you're doing basic Python things, maybe sometimes you don't want data frames because you're not familiar with them. So I have the same function, but instead I'm just doing it as a standard list. So notice here what's happening is I'm returning not the response, but the response hits hits. Because the response captures additional metadata about the return results. And so there's actually the data you're trying to grab and go through is actually nested under hits hits. That's why I'm not returning the whole object. You could always do the whole thing and just print it and see kind of what's in there, because sometimes you want that other data, but if you want your raw log data, you want that instead. From there, we'll try that new one, and notice it's a list that then contains the JSON per log of what matched the search query. So now you could deal with that with any standard Python list interaction. Next, show me all the indices that are in my cluster. Because maybe you don't know, or maybe you're trying to run some type of maintenance routine against all of your indexes. It's part of what we do with this project. So you can see in here, I've got 3 indexes. They're all yellow because I don't have multiple nodes. Well, one of them's green because it doesn't have a replica 0. But the other ones that are supposed to have replicas can't, because I only have 1 node and I need 2 for that replica, so their health is yellow. But we've got our 2 demo indices, and Kibana created its own setting index. So we have 3 indexes. I can change the format a little bit. Here I'm making it JSON, but I'm calling specific fields I want from those indices. So the results are slightly different. And notice here, instead of having the size of the index in human readable like kilobytes, megabytes, I'm saying just give me the raw number, because maybe I want that so I can get a very precise byte count. So there's different ways we can call out what fields we want. You can also sort them with this S. That means sort by creation date. The bytes of B is how I'm telling bytes to be the actual bytes, not the human readable bytes. Let's keep going down here. And one of the things we do in this Elastic Index Lifecycle Management is, rather than just deleting data based on index date, where the date's in the index name, we get away from time-based indices, and instead we try to do everything as a rollover. So winlogbeat-0001. Once it gets to a certain size or age, whichever one comes first, it rolls over into 2, and then into 3, and then into 4, because now you have automatically right-sized shard counts across all your hosts. Well, if you do that, what happens if you actually have 7 days worth of data in one index, and you actually don't want to purge it until the newest document is X days old? Well, one of the things you might want to do is have the date of the newest log in the index. That's what this function right here does. And again, what you can do is copy the function name. Anytime you see es dot, that means reference es.py. So it's grabbing the code out of here, and then here's that function. So get the newest document by date, it grabs the connection, and it's really just running a search, grabs the first record by sorting it, size count of 1, and then it converts the at timestamp back. If there's not an at timestamp field, it falls back to index creation, but hopefully your data does have at timestamp. So we run this, and for our demo data, we get a time of the date of today. Because I'm letting the data, when it ingests the demo data, I just let it ingest as today's date for this reason. So moving along. If you need to do something like a force merge, well, again, force merge, it's optimizing your indices over time. You don't want to do this unless the index is no longer being written to. You just call a force merge on it. There it is. It's done. Is my cluster healthy? Well, my cluster's yellow. My cluster's yellow because I only have 1 node, which is also a data node. Yet I need to assign shards, specifically 2 of them. Those were those 2 that said they had replicas, but it can't assign the replicas. That's where that came from. So that information's there. And then for this project, we read in some global settings from a TOML file, and then we read in per client configs for how to connect to Elasticsearch and policies, because this ILM might actually be running against multiple Elastic clusters at a time. Well, to simulate some of this, I'm loading in the example files, and then I print the settings. So you can see, where are we setting our client folders? Are we checking host names? Is password authentication enabled? And that's where we're pulling these from, because for you, if you're implementing some of this, it's a little bit easier than just doing always hard-coded Python to have configuration files. So in here, it'd be stuff like client JSON. The policies that we enforce are down here for when to delete, when to rollover, when to change allocation from say SSD to SATA for tiering, and then how to connect to the cluster. So that data is there, and then the settings file is kind of the global, like do you want to have the lifecycle management do accounting? Do you want it to notify via Microsoft Teams or Jira? Are rollovers enabled? Things like that. It's just kind of having settings files. So for the demo, I'm going to overwrite some of these programmatically. So here I added a retention for demo. Any index that has a prefix of demo, well, it won't be deleted unless it's at least 45 days old. So down here, if I say check the retention policy of demo Nessus, it should say it's set to the demo policy. So if I run this, it is. That's good. I'm now going to set an even more specific one of demo-suricata. So set a policy. I'm adding a new one, demo suricata, to 40 days. Run it against the demo suricata data we ingested. Notice it says demo suricata. That would be the equivalent of going into the client JSON file, coming down here to retention, and overriding it here where it says demo suricata. So in fact, what I just did where I set it to 40, this right here overwrote my client JSON where it was set to 0. So this is just letting me know what policy would have been applied. And I can do the same thing for rollovers here. And it's set to the global one because I didn't overwrite it yet. So in this case, actually let me make sure I'm reading this. So index policy, rollover for suricata. I'm now changing and adding, running it again, and this time it says demo. So now because there is an entry for something that has a prefix of demo, it would be applied. All right, let's have some fun now. We have an index for demo suricata 1. We have an index for demo suricata or demo Nessus 1. And if I want, I can force a rollover. Notice is acknowledge true. Let me look at all my aliases here for a second. Well, suricata ones. Notice there's now an alias for suricata 1 and suricata 2 to demo-suricata. But number 2 is now the right index, meaning any new data that comes in will be placed in that index. If I go up here and I change this and I say 2 and I run this one again, notice there's now a 3 and it's now the right index and the other 2 are not. But if I query demo-suricata, I can still search across all 3 indexes and it will, which is perfect. So this is how we're forcing the rollovers. And that is actually a really simple function. Go in here. All we're actually doing is we're creating a brand new index, and what we're doing kind of simultaneously here is we're removing the old index but then immediately adding it back as right index of false because it was previously true, and then adding the new index that we created as the writable index. It sounds complicated, but if you go through it, it's actually really basic. Yet this one concept of rollovers and making sure they work properly, that is what has seriously saved some of our clients bacon, because their shard counts go all over the place. Or how about this one? Raise your hand if you've seen this. I have 500, 1,000 shards, but I have X number of Elasticsearch nodes, but they're not distributed equally. Like some nodes are 30% used, some are 90% used. What's going on? Shouldn't it be load balancing? It is, based on the Elasticsearch algorithm, which defaults to shard counts, not shard sizes. If you need help with that, or you're like, that's me, put a comment. I'd love to see if anybody else is having that issue. And if you're stuck and you're like, I need help, reach out to us. We'd be glad to help you out with that. We see that a lot. Rollovers can really help you fix that. So rollovers can really help you out. I definitely would check into them, and if not, let us know. We're glad to help you out. The last thing I want to show you real quick is what if I want to run this as if it was in place now. Now, I do have a copy of the sample files. So for this, you would just literally need to run cp client JSON example to client JSON, followed by cp settings toml example to settings toml. That's for the Docker Elasticsearch to work. And this just simulates running it against this data. So I'm going to apply a rollover policy. There we go. And I'm going to apply a retention policy. Now the rollover didn't have anything to roll over, so nothing happened. Notice here, this one deleted the demo suricata, and that's because the policy said to go ahead and delete it. Now, these are just a couple things we could do with Elasticsearch via Python. Data science, maintenance, coming up with new fancy detections, automatically downloading things like Sigma rules, and then testing and orchestrating and validating them. If data is in Elasticsearch, but you want to run things to enrich it after the fact, I'm usually a fan of doing it with Logstash, but Python, I can do whatever I want. It's beautiful. Check it out. I hope you take the time to download this GitHub repo and go through this manually. If not, I hope you like this video. Stay tuned. I'll have more coming for you.